per Haber's process, ammonia is manufactured in an exothermic reaction. So this we are talking from your Lee-Chatelier principle, which we have discussed in your why it is chosen that temperature should be 450. Catalyst which we use is your iron. Now what does a catalyst do? Catalyst does not change the direction of equilibrium. Very important, the second part of this video is the contact process. In the contact process, what is synthesized? Hello and welcome everyone. I hope you all are doing good. So today we are going to start with your last and final part of your chapter, chemical reactions. I hope you have watched part 1, 2, 3 and 4. If not, then please go check out. You will find the links in the description box below. Here we are going to talk about these particular topics. Let's see. So oxidation and reduction, oxidation number, redox reaction, then Roman number and oxidation number. Then we are going to talk about the rules which are assigned for oxidation number. Then identifying redox reaction by color change. We are going to talk about 2 examples in this. Then oxidizing agent and reducing agent, what are they? And then we'll do some related questions, okay, for our practice. So the first topic is oxidation and reduction. These are 2 types of reactions. One is oxidation, another one is reduction. So together, if both are taking place simultaneously, then that reaction is known as redox reaction, which we are going to talk about in detail in the upcoming slide. So the first is your oxidation and reduction. So in this particular chapter, we are going to understand oxidation and reduction in the terms of electron. Okay, so in one process the electrons are lost and in another process electrons are gained. Okay, but I want to share 2 more different points between them, that oxidation is also addition of oxygen and reduction is removal of oxygen. Then oxidation can also be defined as the reaction in which hydrogen is removed. So we can say that removal of hydrogen, and for reduction it is addition of hydrogen. Then third way in which oxidation and reduction differs from each other is that oxidation means loss of electrons and reduction means gain of electrons. So if you have watched our electrochemistry chapter, then in that I explained you that there is a mnemonic to remember this, OILRIG, oil rig, okay, whose initial stands for oxidation is loss of electron, and reduction is gain of electron. Okay, so this mnemonic we have already seen in that electrochemistry chapter, right? So here we are going to discuss about the reduction and oxidation in detail. So let's read oxidation and reduction in terms of gain and loss of electron, although we have already written, but let's see. Oxidation is the chemical process where a substance loses electron and may gain oxygen atom. Okay, here I have already written oxidation means addition of oxygen or gain of oxygen, then removal of hydrogen or loss of hydrogen, and loss of electron. Okay, these are the 3 important points which can take place, and we can say that this particular reaction is oxidation reaction. Next is your reduction. Reduction is the chemical process where a substance gains electron. Okay, here we have written gains electron and may lose oxygen atom. Here it is. Okay, or may add hydrogen. For example, I have Mg. When it is burned in the presence of air, Mg plus O2, it gives MgO, magnesium oxide, right? So this is a chemical reaction. If I ask you, so here magnesium is undergoing oxidation or reduction. So magnesium, because addition of oxygen is taking place over here, so we can say that this is oxidation reaction, right? I hope this is clear. Please take a minute here to note this down. I hope this is clear. This table is very important. Please note down this table. Now let's move on to your oxidation number. Now what is oxidation number? So what happens? We know, we have read this before also, that there are two type of ions. What are ions? Ions are charged particles, right? Charged species are charged particles. So ions are either positively charged or negatively. Positively charged ions are known as cations and negatively charged ions are known as anions, right? Now, why does the ion form? So when any element either loses electron or gains electron, then they possess a charge over them. For example, if they lose electron, then they possess a positive charge, okay? So that's why we say that metals have tendency to lose electrons and hence they are positively charged species. Whereas anions are the ones which gain electrons. Or I can say that non-metals have tendency to accept electrons and hence they possess a negative charge over them, right? So what happens? As our oxidation state moves from negative to positive, it means that they are losing electron. Positive oxidation state means it is losing electron. If let's say Y have +1 oxidation state and X have +2 oxidation state, it means that Y has lost 1 electron wherein X has lost 2 electrons, okay? And for example, if I say Z have -1 and A have -3, it means that Z has gained 1 electron and A has gained 3 electrons, right? Now, let me clean this. Okay, now let's understand one more very important thing. An oxidation number is a number given to an element in a compound that shows if it has lost or gained electron. Okay, these are of two types, positive and negative. This we have already talked about. For example, X plus Y react to give Z plus A. Okay, here the oxidation state is +2, here it is +3, here it is -1, here it is -2. So if I have to find out where the oxidation or reduction is taking place, then what will we do? We will check. Okay, let me do this. Let's name this X and Y only. Now, over here, X oxidation state has increased. From +2, it has lost one more electron. Loss of electron means oxidation has taken place. From +2, it has changed to +3. It means oxidation has taken place. So remember this, whenever the plus oxidation is increasing, it means they have lost electrons and hence oxidation has to. And in case of Y, what can I say for the Y? So here, because it has gained electron, initially it was in -1 oxidation state, later on it got into -2 oxidation state. It means it has gained electron in this process. Hence, I can say that reduction is taking place over here. I hope this is clear. Now, let's read. An electron is negatively charged, so adding these negatively charged electron to an atom increases its negative oxidation number. So, as the electrons are increased or gained, it means more negative charges will be present, okay? And the opposite happens here, oxidation number increases in plus, okay, if they lose electrons or if they are losing electrons, making it less negative. I hope this is clear. It was very easy. Now let's move on to the redox reaction. As it was mentioned earlier that when reduction and oxidation takes place simultaneously, then that becomes your redox reaction. Okay, now redox comes from two words, RED, which is reduction, and OX, which is your oxidation. Okay, so it is combination of both of them. When both of these reactions are taking place simultaneously, then that is known as reduction. For example, you have zinc. It is reacting with your hydrochloric acid and it gives ZnCl2 plus H2. Now here what is happening? Let's check. So zinc initially was in 0 oxidation state. Okay, here it has no charge, right? So it is 0, its oxidation state is 0. But over here, if we have to find out, its oxidation state is +2. Okay, how did we find out the oxidation state? So let me tell you. Okay, so the oxidation state, if we have to find out for Zn, then what do? We will consider this as X, then plus how many chlorine do we have here? 2, and times each chlorine or each chloride have -1 charge, right? So -1 equals to, the whole is neutral, so equals to 0. So from here you can find out the oxidation state to be your +2. Okay, so that's why I'm saying Zn is converting from 0 oxidation state to +2 oxidation state. So when oxidation state increases, then it is oxidation. Why? Because now it has lost electron. It has lost 2 electrons. Let's talk about hydrogen. So here hydrogen is in its -2 or -1 times 2 oxidation state. Here it is in 0. So from minus it is coming up. So hence I can say it has gained electrons, and therefore this is your reduction. So these are the oxidation half reaction and reduction half reaction. We have already done the writing part, that how do we write out the ionic half equation in your electrochemistry part. So oxidation means oxidation is loss, right? Loss of electron. Zinc atom loses electrons and are oxidized to zinc ion Zn+2, right? This is what I told you here. Then reduction. H plus ions gain electrons and are reduced to hydrogen gas. Okay, here it was in +1 oxidation state. Here it is in 0, right? But +1 times 2, which will give you +2. +2 electron it will gain, and then it will convert into hydrogen gas, right? So redox reaction involves both oxidation and reduction happening simultaneously. This was important. Please note down this. Alright, so I hope you have written this and understood. Now next is your question. Let's check how much we have learned. Which change in the following equation is oxidation? Okay, so what happens in oxidation? Again, the mnemonic oil rig. Okay, oil stands for oxidation is loss and reduction is gain. So we have to check in which element loss of electron has taken place. That will be our oxidation, right? So from V3 plus it is changing to V4 plus. It means that it must have lost one more electron to achieve this +4 charge over it, right? So this is what your oxidation, correct? Next is Fe in +3 oxidation state to Fe in +2 oxidation state. Oxidation state has decreased. It means that it has gained electron and hence reduction has taken place, right? But we have to answer for oxidation only. So our correct answer will be from V3 plus to V4 plus. This is your oxidation reaction. I hope this is clear. Now let's move on to the next part. Okay, here we are going to talk about Roman numerals and oxidation number. Now in your books, in chemistry books or any chemistry related topic, you must have seen such compounds written. Iron 2 oxide, iron 2 ions, or maybe copper 3 ions, or maybe you can see copper 1 ion. Okay, now what does this Roman numeral actually mean? So the Roman numeral which is written in the bracket, this is nothing but the oxidation state of this. Okay, so it actually means that here iron is in +2 oxidations, right? The Roman number written in the bracket is nothing but your oxidation state. Okay, here iron is in its +3 oxidation state. It has lost 3 electrons. Here it has lost 2 electrons. Okay, and another example, for example, which I just gave you, copper 1 ion means copper is in +1 oxidation state. If I have to write copper 2 ion, then I will write copper and then in bracket to mention is oxidation state, which is 2. So in Romans we have to write. Okay, now let's read. Transition elements can bond in different ways by forming ions with different charges. Now what are transition elements? So your periodic table looks something like this. Okay, this is your S block, this is your D block, this is P, and this is F block. So this whole D except the last, this is known as your transition. Now why they are known as transition elements? Because they have unfilled, or I can say that unfulfilled D orbital. Okay, hence like from D0 to D9, right, which is not fully filled, and hence they are termed as transition elements. Okay, next is when naming the charge on the ion is shown by using a Roman numeral after the element's name, which we have just discussed. This Fe plus 2 is known as this. Okay, this Fe plus 3 is written like this. Then, for example, ion can form different ions. Okay, ion can form different ions. Basically, ion can show two valencies, plus 2 or plus 3. Plus 4 also it can show, but rarely. Very often it shows plus 2 and plus 3. Then copper shows plus 1 and plus 2. Manganese show up till plus 7. So, how do we inform in the name that what is the oxidation state in this particular compound? We write it in the bracket. Okay. Then, for example, iron reacts with oxygen to form iron oxide. So, now how do we write the iron oxide? So, here the formula of this product will be FeO. When we are taking iron as 2, its formula will be FeO. Why? Because Fe in plus 2 oxidation state or oxide in minus 2, we crisscross and we get FeO. Right. Similarly, if we have to write this iron 3 ions oxide, it means we have to take iron's valency as plus 3 and oxide valency remains minus 2. Then we crisscross and we get Fe2O3. Okay. So, this is the difference, and this is why it is very important that we mention the correct oxidation state in which the element is present. I hope this is clear. If you wish to note down, you may do so. Okay, now how do we know that which element or in which compound what will be the oxidation state? So, there is a set of rules which are assigned for oxidation number. Let's discuss each of the rule with example. So, first rule is the oxidation number of any uncombined element is 0. Uncombined element is when it is not combined or when it is not in the form of a compound. Okay, so when it is in pure form, like for example H2 or F2 or helium, okay, in this case the oxidation state will be 0. Okay, this is 0, 0, 0. Let's take Mg or Fe. Here, if the oxidation state is not mentioned, that then in any uncombined element it is 0. I hope this is clear. Next is many atom or ion have fixed oxidation numbers in compounds. Okay, so few have fixed oxidation, like for example group 1 elements. Which are your group 1 elements? So, this is your S block, this is your group 1 elements. Okay, wherein lithium, sodium, potassium and all are present. Okay, these all group 1 elements have plus 1 oxidation state always, and the group 2 elements in which beryllium, magnesium, calcium, strontium, all of these have plus 2 oxidation state. So, remember this, group 1 have plus 1 oxidation state and group 2 have plus 2 oxidation state. And fluorine is always negative 1. It means the ones which are present in your group 7, the halogen group, fluorine, chlorine, bromine, iodine, they are like this, minus 1, minus 1, minus 1 and minus 1. Why? Because they need one more electron to completely fill their outermost. Right? Next is your hydrogen, which always has plus 1 oxidation state. Now, remember this, that they are talking about this hydrogen, okay, not the hydrogen molecule. Hydrogen molecule is 0. Here we have learned about this. Here it is hydrogen, just simple H plus 1. Then except in hydride like NaH. So, hydride is, let me clean this. Hydride is your NaH. Here hydrogen is acting as a negative ion, right? So, it will be H negative. So, oxygen is minus 2, we know, except in peroxide. In peroxide it is, what is peroxide? This is peroxide. Okay, where oxygen and oxygen are bonded with a single bond. Here the oxidation state is minus 1. But if it is bonded like this, then it is minus 2. Okay, in F2O where it is plus 2. Okay, now these were some exceptions, so you should know this. This is important, this is basic. Then let's talk about the third point, which is oxidation number of an element in a monoatomic ion is always the same as a charge. Okay, so the valency or the charge which any monoatomic ion has, like for example Zn plus 2. So plus 2 becomes its charge, and hence this becomes its oxidation number also, right? For example, copper plus 1. So this is its charge, it becomes its oxidation number also, right? Next is the sum of the oxidation number in a compound is 0. We know this, that for example Na and Cl, here the complete oxidation number of any compound is going to be your 0. For example, Na, we know it is 1 plus 1 because it lies in your group 1, and Cl is minus 1. So when you add this, you will get 0. Okay. Next is sum of the oxidation number in an ion is equal to the charge on the ion. So this is important. Okay. Similar to the above step only, like for example SO4 minus 2. So if you know the oxidation state of sulfur, plus 6. If you know the oxidation state of oxygen, which is plus 4 times minus 2, you will get minus 2, which is the complete charge on the compound. Okay, let's solve this. 4 times 2 is 8. This is minus 8 plus 6. This will give you minus 2. Right? So this is how it is done. Next is, in either a compound or an ion, the more electronegative element is given the negative oxidation state. Obviously, more electronegative means it is having high affinity towards electron. Hence, like for example, F2O, 2 fluorine atoms. Fluorine is the most electronegative element in your complete periodic table. So, therefore, it is given your negative oxidation state over here, right? So, this is it. For the rules, if you wish to note down, then you can do. Okay, now let's move on and try some questions. So, the first question is, equation for the reaction between chlorine and potassium iodide is shown. So, the reaction is given to us, this one. So, they are asking, identify which species has been oxidized and the one which is reduced. So, which is, what was oxidation? Let me write down again over here for you. This is oxidation. In oxidation, what happens? Addition of oxygen or loss of hydrogen or loss of electron. Okay, in these three terms, we can understand oxidation. Then opposite of this, which is loss of oxygen, addition of hydrogen and addition of electron. Right, now let's understand the reaction. Here chlorine is in its 0 oxidation state, right? Because in the rules also there was this mention, the oxidation number of any uncombined element is 0. So this is uncombined element, right? So let me erase this. Okay, now let's talk about this. This is going to be 0. This is also uncombined, so this is 0. I hope this is clear. Now over here, potassium or iodine, let's say iodine is in minus 1 oxidation state, and over here chlorine is in its minus 1 oxidation. Okay, so Cl2 changed from 0 to minus 1 oxidation state. It means that it has gained 1 electron, and if it has gained electron, it means I can say that reduction has taken place over here, and therefore the species which is reduced is your Cl2, and here I minus changed to I to 0. From minus 1 oxidation state, it is converting to 0. It means it has lost 1 electron, and hence this is your oxidation. And therefore, we can say that CAIE has been reduced or CAIE has been oxidized, right? To I2. Okay. Next is your question. State the oxidation number of the transition metal ion in silver 1 chloride. So here, what is the transition metal? Silver is the metal. Okay. We always write the species first, which is your metal. So here, silver is the metal in plus 1 oxidation state. How do I know this? Because in bracket 1 is written. So for first question, the answer will be that state the oxidation state Ag is in plus 1 oxidation state. Okay. Answer number 2. Name including Roman numeral the compound with formula COCl2. So here CO is cobalt. Okay. So let's name this. This is going to be your cobalt. Then its oxidation state, and then chloride, right? So what is the oxidation state here? X minus 2 equals to 0, X equals to plus 2. So oxidation state over here is 2. We will write this in Roman numerals. Okay. Next is this question. Explain which chemical that are reduced and oxidized in the reaction between iron 3 oxide and carbon monoxide. Okay, this is carbon monoxide. So which one is reduced and which one is oxidized? Let's check. Here if you can see carbon monoxide, addition of oxygen has taken place. From CO it has become CO2. It means addition of one oxygen has taken place. I can say this is oxidation reaction. And so this becomes your reduction because loss of oxygen is taken place, right? So which species is oxidized? Oxidized is your CO, and reduced is your Fe2O3 or iron 3 oxide. Okay, I hope this is clear. You can note down the answers. Alright, now let's move on to another very interesting topic. So, identifying redox reaction by color change. So, sometimes what happens that we have to identify what type of reagent is this. Is it an oxidizing reagent or a reducing agent? Now, what are oxidizing and reducing agent? First, let's understand that. Then we'll come to this reaction. So, what are oxidizing and reducing agent? So, the agent or the substance that oxidizes another substance, but it itself get reduced, that is your oxidizing agent. Okay, an oxidizing agent gains electron. This is important. What is an oxidizing agent? It itself get reduced and help the other to oxidize. Okay, then oxidizing agent gain electron as another substance loses electron. And here what is reducing? Reducing agent loses electron as another substance gain electron. Okay, this is important. What is reducing agent? The substance which itself get oxidized but reduces the other. Okay, this is very important. Next, so we have an example, CuO, which is your copper oxide. It reacts with hydrogen to give Cu plus H2O. Here they are asking which one is oxidizing agent and which one is reducing agent. So let's understand the explanation. Hydrogen is reducing the CuO. Why? Because here reduction is taking place. Let me this here, this is reduction because loss of oxidation is taking place, right? And this is what your oxidation. This is your oxidation. Okay, now what is happening? Hydrogen is your reducing agent, reducing the CuO. Okay, so CuO is reduced to give Cu, right? Now CuO is reduced by hydrogen, and so the reducing agent is hydrogen. This becomes your reducing agent. So wherever the oxidation is taking place, that becomes your reducing agent. This becomes your reducing agent. I am writing Ra, and this becomes your oxidizing agent. Okay, oxidizing agent means a species which is gaining electron. Okay, here we have already understood. Then this is a flow chart kind of a thing which will help you to understand this really well. So for example, A, B, B. So if A donates electron and B gains electron, this is losing electron, this is gaining electron. So the species which loses electron means it is a reducing agent. Okay, and the one which, okay, and the other species is oxidized, then the one which gains electron is your species which is reduced, right? So this is like that. Don't confuse with the names, just understand the concept. Now let's talk about this part. Okay, so how do we identify redox reactions by color changes? Let's see. It involves the observation of color change in the solution being analyzed. Two common examples. So we are going to talk about two common examples which I told you, which is acidified potassium manganate 7, and second example is potassium iodide. Now let's take up both of these one by one. First is potassium manganate 7, KMnO4 is an oxidizing agent. So we should know that it is an oxidizing agent. Oxidizing agent is the one which itself get reduced and it oxidizes the other element, okay, which is often used to test the presence of reducing agent. Now what do we do? that we have this purple color KMNO4. Okay, and then when acidified potassium manganate is added to a reducing agent, its color changes from purple to colorless. So if in any beaker a reducing agent is present and if we add the potassium manganate, which is an oxidizing agent, into it, then the color of KMNO4, which is your potassium manganate, changes from purple to colorless. Okay, next example is your potassium iodide. So potassium iodide is your reducing agent. Now what is reducing agent? The one which itself get oxidized and reduces the other. Okay, which is often used to test for the presence of oxidizing agent, just the opposite. So when we add acidified solution of oxidizing agent, so any example we can take for oxidizing agent, let's suppose H2O2, which is your hydrogen peroxide. When we drop few CAIE drops into H2O2, then the color changes from colorless to brown. Okay, the solution turns a red-brown color due to the formation of iodine. The potassium iodide is oxidized as it loses electron. What is oxidation? Oil rig. Okay. Next, the hydrogen peroxide is reduced. But what was hydrogen peroxide? It was an oxidizing agent. So the opposite happens. Therefore, potassium iodide is acting as a reducing agent. So this is important. Please make notes of it. Okay. And this we have already done. What are oxidizing and reducing agents? So here we come to an end of your chapter chemical reaction. I hope this is clear. Please try a few questions and let me know how did you understand the topics. If you have any doubt, feel free to comment down below and I'll get back to you. And I'll be coming with the 7th chapter really soon. Till then, keep learning. And thanks for watching and I'll see you in the next video. Till then, don't forget to like, share and subscribe to our channel.